This is going to be a shout out to Bob the Science Guy. Thank you for the idea. Something that Bob the Science Guy said was he's recently talking about gyrocompasses and explaining how they work. And I thought to myself, it would actually sound like fun to build my own. And I'm not really interested in building anything elaborate. I just want to build this thing to see how it works, because I kind of believe that the best way to understand how something works is to try to build it yourself. So I'll go on the internet and find a picture of how a basic gyrocompass works. After doing a little bit of research after watching Bob's video, the way I understand how this works. So you've got a spinning disc like this in one plane. So let's say this is the gyro axis. I was just trying to figure out how what they called it. So this is the gyro axis. And basically this means that the gyro is spinning in a direction. So it can either spin in that direction or in the other direction. But the way I understand how a gyroscope works is it will resist movement in the other two directions. So you can think of the gyro as being on in one dimension, and then you've got in the other dimension you've got this here, so that would be like the horizontal axis. Horizontal axis. And then you've got in the other direction, in the third dimension, you've got this one here, which is the vertical. And you can imagine that if you want to try to move the vertical axis towards the direction of the horizontal axis, that's what I was trying to describe. That seems to work, and in either direction. So you can either try to move the vertical axis towards the horizontal in clockwise or counterclockwise direction. So that's basically what I was trying to say. But my understanding is that as the gyroscope is spinning, it's got inertia on the gyroscope axis. And so if you try to move either the vertical axis towards the gyro axis like this, so if you're trying to move the z-axis towards let's say the gyroscope is on the x, the horizontal is on the y, and okay, let's label this. So let's call this the x. Let's call this the y, and let's call this the z. So if you try to move the vertical axis, the z-axis, towards the x, which is the gyroscope axis, the gyroscope will resist that movement. Likewise, if you try to move the x-axis towards the y-axis, or the y-axis towards the x-axis, again, you're trying to displace the orientation of the x-axis, and that ends up resisting. So that's the way I've always understood the gyroscope to work. But what Bob said, which was kind of interesting, was what you call gyroscopic precession. Let's say, for example, the gyroscope is pointing northeast, for example, not north, not east, not up, not down, but just kind of like pointing horizontally in a northeasterly direction on the equator. It's going to apply a bit of force on all three axes. But what's going to happen is over time, because you've got that torque being placed on the Z towards the X and on the Y towards the X as well. What happens is the gyroscope will resist the movement in the X and the Y directions, no, the X direction, and it ends up twisting more towards the north over time. Like we're talking, I think it's hours or something like that. I looked it up online, and they were saying that a gyrocompass that's used in something like a ship, if it stops spinning, you want to regain true north as quickly as possible. So you kind of give it a bit of a helping hand and move it as close to pointing north in the northerly direction as quickly as possible, so that, or as much as possible, so that when you spin it up, it's got the least amount of compensation that it has to do to get it back pointing north. Otherwise, if it's pointing in any old direction, I think they were saying it can take several hours. So that is my understanding of gyroscopes, and the fact that a gyroscope will precess towards the north. So the plan is I want to build a gyrocompass. And the way I plan to do this, I have a couple of 3-volt hobby motors. I've got a small 3D printer that I can design all the various parts, and I don't really know exactly how I'm going to build this just yet, but one thing that I can do is build it from the inside out. And because it's just basically a rotating disc attached to an electric motor, what I plan to do is design the gimbal around it. So the electric motor and the gyroscope, the flywheel, these are what's spinning on the gyro axis like this. And all I have to do is basically make myself a frame that clamps onto the motor and provides an axis of rotation this way. Now, I think what I'm going to do is I want to make the flywheel as big and as heavy as possible to give it the most inertia that I can give it. Because this is coming out of a 3D printer, it is essentially plastic. Plastic really does not weigh much, and I want as much inertial mass as I can get. And I think they were saying that a gyrocompass has a typical weight of anywhere between 3 pounds to 25 pounds, I think. I don't really want to, so the printer is not really that big, but it's just basically proof of concept, and if I can give it enough mass so that it can actually capture the rotation of the Earth and even point towards the north, that was the entire goal. But having said all of that, I want the flywheel to weigh as much as possible. And because of that, I don't want the horizontal axis to be right here, because that will make it heavy on the flywheel. So I'm going to have to figure out, I'll start by creating the flywheel and then try to find out where the balance point is of the motor. And I might end up printing a couple of arms that extend out like this, and from there more or less figure out where the balance point is and maybe put the pivot somewhere around here for the horizontal axis. Then once I've got that, if I look at it from the side, so here is the motor, here is the flywheel, and if I'm probably going to end up doing something like this here. This is going to be kind of like the, this will probably be the, this frame right here. So I'll probably end up, I suspect, maybe probably put the pivot point right about here, the horizontal axis pivot here. So that's going to be what it looks like on the side, and on the top it'll really look more like that. Then I am going to build a separate frame that's going to look, I'm probably going to end up building a like a bushing block that these pivots over here, those guys right over there, will end up sliding into. So I'll probably end up, if I come back over to here, these are probably just going to be something like, I've got some like 1/8 inch metal rod I think I picked up at the hardware store, and I'll just cut it to length. One part of it is going to be, I'll probably bore a hole in here, or not bore a hole, but I'll make it with a hole that I can cut a small piece of the metal rod and then just push it in. That'll then have a part of the metal rod that sticks out, and then that can kind of over here, if we look at this from the side, the pivot block will probably be like this here. In fact, I'll probably even extend this beyond for a couple of reasons. Mainly to get power to the electric motor. I'm even thinking of using this as an electrical positive, and maybe this one here as an electrical negative. And that can then carry on electrically to the vertical axis gimbal, and this one here probably end up having a couple of metal rods that go like this to a couple more base ones, and then kind of repeat the thing over on this side, and then a couple more little blocks over here, and then join these two together like this here. So I can kind of maybe create this vertical gimbal. I'll actually need another block over here where this one can pivot. So this one, this gimbal would allow rotation in these directions, and of course this one would allow the whole thing to rotate in this direction, and then of course this the flywheel would want to rotate in this direction. Final assembly, I'll try to find a few pictures on the internet and kind of insert it in this video to see how to show you what it'll look like more or less. That's where I am at the moment. If you like this, give it a big thumbs up, and like, share, subscribe, all that other good stuff, and leave a comment, and look forward to the next one, because I am actually planning to do this and go forward and share the results. So, bye for now.